Okay. Hi, my name is Martyn Moreno, and this is my Milestone1 submission for PlantPal. PlantPal is a smart houseplant care companion app, and it helps users track and care for their plants. For Milestone1, I implemented the plant database integration feature, which allows users to search for plants using the Perenual API and save them to a local database. Now let me demonstrate the app real quick. Here you can see the main screen once I open it, showing no plants yet, because obviously we haven't added any plants. Now when I tap the plus button here, um, uh, it takes me to a plant search screen, and I can search for any plant using the Perenual API. Now in this case, I'll do sun, so I'm going to do, it's a Japanese Sunago Japanese maple. So when I search, the app sends a request to the Perenual API, and it displays the results with plant names and thumbnails. And when I select a plant, like right here, I'm taken to the registration form where I can customize the details. So let me fill in this form real quick. In this case, I'll do my Japanese maple. And then medium, I'll leave it there. Room location, let's do dining area. Light condition, I'll change it to bright. Okay, and then from here, I can just click save. Once I save it, the plant appears in my collection. The data is persisted in a local room database, so it will be there even if I close and reopen the app. Let me demonstrate that for you really quick. So let me swipe up, close it. If I open it back up, it's still in my collection. Perfect. So now I'll do a quick code walkthrough. So first one I'll go through is the plant. So hold on. Okay, let me minimize this a little bit. Okay, so first is the plant entity. This is a room database entity that defines the structure of the plant record. Has fields for the species ID from the API, nickname, common name, scientific name, watering frequency, pot size, room location, light condition, and a thumbnail URL. The entity annotation tells room to create a table for this class, excuse me. Okay, next is the plant DAO. So this plant DAO, so DAO stands for Data Access Object. This interface defines the database operations, so the get all plants, and then that returns a flow so that the UI automatically updates when data changes. I also have insert, update, and delete operations using room notations. Next one I'm going to do is Perenual API. So this is the Perenual API interface using Retrofit. It defines the search plants endpoint, which takes an API key and search query and returns a list of plant results. The base URL points to perenual.com's API. Next one is going to be plant repository. This one has a little bit more, so I'll scroll down. So the plant repository, it acts as a single source of truth for the plant data. It combines the local database and remote API. The search plant function calls the Perenual API, and add plant saves to the local room database. This follows the repository pattern which separates data logic from the UI. Okay, and the next one I'll do is plant view model. Okay, and the plant view model, it manages the UI state using Kotlin StateFlows. It holds the search query, search results, loading state, and selected plant. When the user types a search, it calls a repository. When they save a plant, it creates a plant entity and saves it through the repository. Okay, finally this is the main activity. This ties everything together. It sets up the room database, creates the Retrofit API client, and initializes the repository and view model. The UI uses Jetpack Compose and switches between the collection screen, search screen, and add plant screen based on the current state. Let me scroll down through this a little bit slower. Okay, now I'll do the clean build and explain the architecture really quick. Build, clean project, wait for it to load, and then show the build was successful in 505 milliseconds. So going through here, so let's close most of this like that. Go to main, Java. And then I'm going to go through each one of these. So data, show you guys data local, data remote, data repository, and then the UI sections as well, right here, and the view model. Okay, so my project follows the MVVM architecture, so model, view, view model, and then let me explain how each layer pretty much contributes to the build. So the data layer has three parts here. It has the local, remote, and repository. And the local package contains room database classes, so the plant entity, plant DAO, plant database. Let me expand that. As you can see, there in the build, the room annotation processor generates the actual SQLite implementation code for my annotations. The remote package, let me open that up as well. The remote package contains my Retrofit API interface and data classes for parsing JSON responses from Perenual. The repository combines both data sources into a single interface, so that's this one right here. And then going down to UI, I have the UI screens and UI theme, and let me pull them up. So the UI layer contains my Jetpack Compose screens, so plant search screen, add plant screen, plant collection screen. During the build, the Kotlin Compose compiler transforms my composable functions into optimized UI code. The theme package defines colors and typography that gives the app its green plant themed appearance. Now going down to view model here. And then the view model layer just sits between the data and UI. It holds the application state using Kotlin StateFlows and handles user actions. This separation means the UI just observes state changes and the view model handles all the business logic. Opening, let me see, I have it open here somewhere. Okay, this one. So the build is configured in this Gradle file. You can see the plugins, the Android application plugin, Kotlin for compilation, Compose compiler for UI, and KSP, which is the Kotlin symbol processing plugin that Room uses to generate database code at compile time. So let me scroll down and show dependencies. You can see. Okay. So dependencies section lists, it lists all the libraries, Room for the database, Retrofit for API calls, Coil for loading images, and the Jetpack Compose libraries for the UI. Gradle downloads these and includes them in the build. So let me scroll right here, and then I'll just do build again and clean project and watch as it loads everything and build successful. Again, you can see the Gradle executing tasks. It's compiling Kotlin code, running KSP to generate room database classes, processing Compose compiler for the UI, merging resources, and then finally packaging everything into an APK. The build completes successfully with no errors. Now going into some of the hurdles and some of the research I did for this. For this milestone, I researched a few pieces of key technologies. First, I pretty much studied Perenual API documentation, so I can better understand how to search for their plant database or how to use it. The API returns plant species data, including common names, scientific names, watering requirements, and thumbnail images. I learned how to structure my retrofit interface to match their endpoint format. I also researched Room databases and their best practices. Room is an abstraction layer over SQLite that uses annotations to generate boilerplate code. I learned about using flows for reactive data. This means when I add a plant to the database, the UI automatically updates without having to manually refresh anything. And then for the UI, I researched Jetpack Compose and Material 3 design. Compose is Android's modern declarative UI toolkit. Excuse me. Instead of XML layouts, I write UI as Kotlin functions. This made it easier to manage state and create a responsive interface. Now, I will say that this project did take me many hours, and I did face a few hurdles that kind of slowed me down. The first major hurdle was the API integration. When I first tried to call the Perenual API, I kept getting 404 not found errors, and I had to go through logcat and the outputs to check what was going on. And for that, I kind of had to ask a few. I was asking cursor, I asked Claude to see what was going on, and I realized my base URL and endpoint path were misconfigured, so the API documentation showed the correct format, and once I fixed the URL structure in my Retrofit interface, the searches started working. The second hurdle was the Gradle dependency conflict, so I ran into an error saying that it was inconsistent with JVM target compatibility. The Java compiler was targeting version 11, but Kotlin was targeting the version 21. I had to add a Kotlin options block to my build.gradle file to explicitly set the JVM target to 11 for both. And this is a common issue when mixing Kotlin and Java in Android projects. And the third hurdle, I'd say, was it was Jetpack Compose compiler setup. So initially, my composable functions showed errors like cannot access class, composable function, and like a number, I think it was 1. This was because of the Kotlin Compose compiler plugin wasn't really properly configured. I had to add the correct plugin to my build file and ensure the Kotlin version matched the Compose compiler version. And I think one of the final challenges I had before I finished was the UI state management challenges. Um, so when the user pressed the plus button, nothing happened. So you would press it, click it, nothing. You would restart the app, really couldn't do anything. So I had to add a separate state variable to track whether the search screen should be shown rather than relying only on the search query being empty or not. And then through a few debugging with Logcat, reading documentation, changing the code, asking a model to see what's going on with my code, I was able to resolve all these issues and complete the plant database integration feature, successfully within a few, I'd say, 7 to 8 hours. And then that concludes my Milestone 1 submission for PlantPal. The app successfully integrates with Perenual Plant API. It allows the user to search for plants and persist through their collection in the local room database. And thank you for watching.